Database is probably one of the most critical parts of your business if you're a tech company, because if your database is down, then chances are that every service linked to it would be affected. And managing databases has been one of the biggest hurdles ever, right? In a journey of getting developers, building software, building businesses, you also want to make sure that as you're growing, you don't go down. Now, obviously, there are many popular database choices like Postgres, MySQL, but hosting them in a scalable way is another complexity in general. That is where providers like PlanetScale come into picture, which PlanetScale is a company that traditionally only did MySQL, but yesterday something interesting happened where they announced Postgres as a service. Now, this was surprising to many because PlanetScale has historically taken a stance that they only want to focus on MySQL. They don't want to get into Postgres. At least that's what the vibe came off as a company. But this was a very welcoming change, which yesterday happened when they announced people can finally use PlanetScale for Postgres as well. This is still in invitation mode, so you don't have access to it directly. Even if you just sign up and start tinkering around, you won't get that access. But it's here now. And it's not like Postgres is not a solved problem. It is a solved thing. It's not like there are no providers as such or nothing is there. The interesting thing, the reason I like this in general is because of 2-3 main reasons. I'll get to them. But if we look at providers like Amazon Aurora or AlloyDB from Google or even Neon or Supabase, you would see that one of the things that PlanetScale offers, even if you don't understand anything, you would understand that the database is fast, right? So you see these connections, you see these performance over 64 connections with Amazon Aurora versus PlanetScale. You can see that PlanetScale obviously is performing much more queries per second. Similarly, for latency, PlanetScale is much more optimized for latency. And similarly, if you go ahead and look at some other benchmarks, for example, for Neon, you would see that the difference is even more, right? So even in case of latency, and queries per second that you are doing, and in general the stability and consistency of the platform is much more. So there are a couple of things that they are doing. For example, if you look over here, you can see that they also say that we are giving a PS bouncer, a PlanetScale bouncer most likely, which is a replacement for PG bouncer. I mean, it's so new that Google does not even index this term right now, but they do support Postgres 17 and support online imports from any version greater than Postgres 13, as well as automatic Postgres version updates without downtime. So one of these things, one of the main components of PlanetScale in which it excels as its reputation is the ability for having a highly resilient system, right? Let's take a look at how they achieve this, because on paper, it seems like it's relatively easy to do, but there are a lot of things that can go wrong. So obviously it requires some serious engineering. The basic idea is that you always at all times have 3 database. So you have this one primary instance and then you have this replica and replica, right? So these replicas are synchronized with primary at all times, right? So the idea here is that PlanetScale's engineering, where it comes in, is it's somehow able to, whatever queries are coming in, for example, certain write queries are coming in, they are passing through another component, which is what they call as VT gate, if I'm not wrong. So they pass it to this component, and then this is the one which is supposed to, figure out like which query should be sent to which part of the database and so on. This component is also able to do failovers or, handle in case something goes wrong with primary. Like let's say the hardware of this instance somehow magically just gets corrupted or something happens. In that case, without any downtime, you have a replica that can be upgraded to primary, and meanwhile you can just recreate a second replica again, right? And again, I think these are done in various availability zones. I don't think PlanetScale does a regional replica. It's still in a single region. So I do feel like if your region goes down as a whole thing, then obviously like the database itself would also be inaccessible, but they do have replica in different availability zones. A region outage is, by the way, very, very rare. It has rarely happened that a region has gone down. I think I remember that one instance when US East 1 went down on AWS, and that took like half the internet down with it anyway. So yeah, then you have other problems to take care of once the region is down. But this is the architecture fundamentally, right? As far as I understand, this is the architecture which allows you to enable high availability, allows you to enable failovers in case you want to do something. One of the benefits here, for example, is that let's say if you want to do some update to the primary database, right? You want to make some configuration change, or you want to, I don't know, maybe like increase storage or something. The easiest way for doing that is, instead of touching primary, you do that on a replica, then you fail over. For example, let's say this device had 100 GB, this computer had 100 GB SSD attached with it, right? Now the way PlanetScale works, at least PlanetScale Metal works, is that this SSD is actually physically attached to this computer over here, right? It's not a EBS or something which you can just increase the storage on the back end. So you actually have to change the computer without, stopping it. So in that case, what you will do is you will upgrade the storage here and you will perform a failover where replica becomes primary then. And then once that happens, you can remove this, you can upgrade this, and you have basically, a third replica now without any downtime as such, right? So this is a cool thing, a feat of engineering that they have to do. But obviously they have to do a lot more with Postgres. I am not very sure about MySQL, but with Postgres, you need to have this PG bouncer sort of thing, which also acts like, we have talked in depth about what PG bouncer is, how this works. So PG bouncer, or in this case, PS bouncer, what they are calling, this is the one that is supposed to accept a lot of connections, right? A lot of connections coming from serverless services or servers and so on and so forth. And then it's supposed to route it to an equivalent of VT gate and then to the actual primary instance, right? So the thing is that all of this technology, in one form or another, is still possible with other providers. But historically, if you look at platforms like Amazon Aurora, for example, Aurora serverless V2, I have personally also used, not exactly this one, but Aurora serverless V2. It's insanely expensive compared to PlanetScale and in general, like a lot of these providers, right? Stability wise, I'm pretty sure like it's great. We did not have any issues with Aurora as such. AlloyDB is also extremely good. We have been customers of AlloyDB as well. So for the most part last year, our database was on GCP, AlloyDB. So it's good. But again, I think in terms of cost, it would be much cheaper, or at least like slightly cheaper. So you can see a little bit of cost comparison here, which says that a PlanetScale M320 with 929 GB of storage cost $1,400 a month on PlanetScale. AlloyDB's cost structure on the same thing is around $1,600. So, in terms of costing, I would say that Alloy is not as expensive. If you're already spending like $1,400 a month, you might as well just put $200 more and keep your same cloud provider if you get the VPC benefits and so on. But the performance, I think if you are behind performance a little bit, then maybe like PlanetScale can even help you there. But even in case of Google, for example, at least in these two graphs, you can see the query per second is not extremely far behind, right? And the reason for that is very clear because, look at Google. Google is the company that created Spanner, right? Spanner, I don't think PlanetScale has done a little bit of thing here that they haven't compared Google's Spanner instance here. Because if you look at Spanner from Google, you would see that it also supports Postgres, or at least the Postgres syntax. I don't exactly know if this is like fully Postgres compatible, but this is the big database, right? This is what powers YouTube. This is what powers Google's critical infrastructure, and this is horizontally scalable. PlanetScale, I think, is not horizontally scalable as far as I know, again, in my limited understanding of how big databases work. So they are putting up, they will be sharding and they will be like partitioning your data and so on, but it still will be like one primary. Spanner, on the other hand, is horizontally scalable, and Google Spanner obviously provides a very high SLA as well. It'll come with its cost, right? It's like a really good database, Google Spanner. I don't know how performant it is compared to PlanetScale. Maybe PlanetScale is still performant because this is like a global, it follows like some properties, like it's very strong asset with true time ordering. So even if you have like regional redundancies in Spanner, this would probably want to copy the data before it returns the write. So it might be slower than PlanetScale. But yeah, it's interesting that PlanetScale does not include Google Spanner over here, which is something I would want to see. But in terms of Neon, Supabase in general, it crushes the benchmark. So even in case of Neon, you can see the cost component over here. The same instance, which they mentioned in Google's AlloyDB, cost $1,400 a month. Over Neon, this starts at $3,085 a month, which is extremely large difference, right? If you compare it now, which is more than double the cost of their basic instance, right? On top of this, Neon has an extremely bad record of uptime, right? So this is something which has absolutely pushed us away as well as customers. We really wanted to consider Neon, but Neon is not a good service if you want peace of mind, right? I don't know when was their last outage, but it wouldn't be that far. I just opened US East one and you can obviously see 4 red checkboxes checkboxes over here. So yeah, this is something, the amount of time Neon has gone down in the last few weeks and months is not acceptable at all as a database provider. So this is something which really puts me off as a customer for choosing Neon. And Supabase is interesting because Supabase itself is working on a V-test for Postgres, but I don't know like how they will react with this. So if we take a look at Supabase performance over here, you can see queries per second. It absolutely, PlanetScale absolutely crushes Supabase over here. Same for P99 latency. It's extremely less compared to Supabase and extremely stable also. So you see like these jumpy spikes. That just means that it's very, very like, not consistent in terms of how performant the database is. Similarly, for queries per second, you can see even in this metric, it's almost like double in terms of performance. Same for TPCC benchmark, P99 is, PlanetScale absolutely crushes it. Same for query latency in terms of microseconds, again, more than double. And I mean, the best part, it's actually cheaper to run a PlanetScale instance compared to a Supabase instance. So I don't think that except for Google's AlloyDB, I actually saw anything that made sense even cost wise, right? Let's just quickly look at all the pricing components first. So you can see Aurora is $1,800 a month on this similar setup, but with worse performance compared to PlanetScale and certain metrics. AlloyDB I have seen is probably the closest in terms of cost, but not in terms of performance. Again, it starts at $1,650 a month compared to $1,400 on PlanetScale. Then Neon is absolutely crushed in this release. And I have zero idea like why somebody would keep on using Neon when they have PlanetScale and Postgres together. 1,400 versus over 3,000 USD a month for Neon. Similar story for Supabase. I don't know why somebody would prefer using Supabase for database. I know like it's a backend as a service, so it offers like a lot of things. But if you're primarily spinning off a Postgres database on Supabase, probably it's time to consider a better alternative like PlanetScale. Or even, I mean, like at this point, why not just go ahead and do it on AlloyDB? It's still cheaper and it comes with the backing and infrastructure of Google. Crunchy data is something I've seen, but I have not used it and I've not like read a lot about it, but I know like this is a provider. But even in this case, you can see like the benchmarks are obviously supporting PlanetScale heavily. And the cost for this is also just around, I would say, Google's AlloyDB. And I mean, this line remains same for everyone, right? So the PlanetScale offers better performance at lower cost and applications for applications that require high availability and resiliency. And similarly for Tiger data, we can see that again the performance is much better for PlanetScale, and this is even worse than Neon, right? So bringing a total of at least 3,500 a month, even worse than Neon. And finally, Heroku, I don't know if that would be my choice at all. Just look at this. Look at the amount of queries per second Heroku is able to handle, 1,000, and PlanetScale is able to handle, which is like 18 to 20,000. A 20x difference in performance. Similarly here, at least a 10x difference in latency. And almost like double the price. I mean, who in their right mind is actually using Heroku for any sort of mission critical workload, which you can see, which requires more performance, less latency, and even cheaper cost, right? So, I mean, it doesn't make a lot of sense, to be honest, at this point, until and unless you have some sort of contracts or credits running on with Heroku in general. But yeah, this is a good competitor for a lot of these companies who have been doing database hosting as a service. And PlanetScale is also very, very stable historically, because we haven't seen any sort of downtimes as such for companies which use PlanetScale, including Slack, Cursor. I mean, at least not the database level downtimes. Obviously, there could be downtimes based on their APIs itself. These logos give you a little bit of trust in the service, right? And plus, the team behind PlanetScale is also people who earlier used to work at YouTube and at Google, building V-tests and MySQL. Obviously, Google does not use V-tests and MySQL now. They use their own spanner, but still, like the engineering and the efforts that it took to create, I mean, that's also on their homepage, right? Well, I think they have changed it now because they are now doing Postgres and V-test both. So they have made it a little bit of more generic. This is very cool. So yeah, let me know what do you think about this in the comments below. That's all for this video, and I will see you in the next one very soon.